Okay, good morning to all. Myself Dr. Digvijay Patil, and we are starting for this chapter orthographic projection and projection of point. So this is the elephant. So we are taking the example of a elephant as our object. So what is orthographic views? Orthographic means single view. Means you are looking towards the object in a single view. That is, you are looking towards the object from front view, or from the top view, from the side view, or from the right hand side view, left hand side view. These all are views are the orthographic views. Orthographic means single view. So single views are the two-dimensional views. So for two-dimensional view of figure, so what we require? We will require length and height, two dimensions, length of a object and height of the object. So for this elephant, we are looking from the front. So this is our front view. This is our front view. We are looking from this side. So this is the front view. Whatever elephant look like. So both eggs, back side legs, front side legs, the trunk of elephant, teeth of elephant, ears. So we will look at as a front view of the elephant. So we are looking from the front. This is the front view. This is the object. We are the observers, and we are making the view of the elephant on the some plane. So we require plane for the views. Now you can see observer, we are the observer. So this is our object, and the back side is the plane for that projection. So now if you are looking towards this elephant from the top, we get the top view, and top view on what? On the ground. We get shadow. If sun rays at 12 o'clock, 12 noon. So from the top, get shadow of the elephant exactly on the ground, exactly beneath of this elephant. So we got the top view or top view projections of that elephant. This is our object. So if you are looking from this side, so we get the right hand side view. This is our front side. This is our front side. We are looking from this side. So this one is the right side of our front side. So we get right hand side view of the elephant on the left of the front view. If we are looking from this side, that is back side, so that is the left side of our hand. So left hand side view on the right of the elephant. So here example is elephant. So normal people will draw the drawing of elephant like this. So how engineer will draw? So elephant. So draw an elephant, engineers. So this is the front view. We are looking from the front. So this is the front view of the elephant. So projections, we got the here back view, or we can say left hand side view. So this is the front view, or we can say right hand side view, and this is the top view. So for every drawing or every orthographic view, we require two dimensions. Here what we required? We required length of the elephant and height of the elephant. This means for the front view, what we required two dimensions of the object, maximum length of the object, maximum height of the object. Front view, so we are getting front view. So this is the coordinate system. On this coordinate system, we get here front view. In front of the observer, in front of the observer, we got here front view. This is the front view of the elephant. If we are looking towards the elephant from the side, if we are looking from the elephant from the side, that is left hand side, so we get this view. So this view is called as the left hand side view. This view is the left hand side view. Now on this left hand side view, what dimensions we require? So this is the width of the elephant, and this is the height of the elephant. Width and height. What we require here? Width and height. So it is the left hand side view. On this side, we get the right hand side view, and for right hand side view, what we required again? So this is the width, and this is the height. Width into height. So here we required width. Here we required width into height. Here we required length into height. Here we required width into height. So we are looking from the top now. This one is the top view. What we required? Two dimensions again. This is the length of the elephant and width of the elephant. So now we are looking towards this elephant from all the sides, that is front side, top side, left hand side, right hand side, and this is the orthographic views of the elephant. Okay, moving further. So these projections, these views were obtained on some plane. So which planes? So those are the planes are the reference planes first of all, and other are the auxiliary planes. So classification of planes: reference planes and auxiliary planes. Reference planes are the principal planes, HP and VP, horizontal plane, vertical plane. Auxiliary planes are auxiliary vertical plane, auxiliary inclined plane, and profile plane. So in principal planes, we have horizontal plane, the plane parallel to the ground. So on the plane parallel to the ground, we get the projection of the, which projections we are going to get? So top view projections. So if this is the object, we are going to get the views of a top view on this horizontal plane. If this is the object and we are looking from the front, so projections of the front view we are going to get on this vertical plane. So on vertical plane, we are going to get front view of a object, projections of the front view. On the horizontal plane, we are going to get top view of the object. So in auxiliary planes, the planes are perpendicular to the horizontal plane or vertical plane and inclined to other plane. So in auxiliary vertical plane, the plane is perpendicular to the horizontal plane. Auxiliary vertical plane is perpendicular to the horizontal plane and inclined to the vertical plane. So now you can see here, this plane is perpendicular to the horizontal plane. So this angle is 90 degree and this angle is some inclination, that is not a 90 degree. So auxiliary vertical plane. What happens in auxiliary inclined plane? In auxiliary inclined plane, you can see that the plane is perpendicular to the vertical plane. Now plane is perpendicular to the vertical plane and inclined to the horizontal plane. So we got condition: plane perpendicular to the vertical plane or plane perpendicular to the horizontal plane and inclined to other plane. So in profile plane, we get condition like plane is perpendicular to the both the planes, both the principal planes. So this is the profile plane. So this plane is perpendicular to the vertical plane as well as horizontal plane. The plane is perpendicular to the vertical plane as well as horizontal plane. If this plane is at the end position like here, so this is on the right side of the vertical plane, so it's called as a RPP, right profile plane, right side of the vertical plane. If you are looking from this side, this is your observer, front view on the vertical plane, top view on the horizontal plane, and RPP, that is right side of a profile plane, or RPP, right profile plane. So on left side you get the LPP, left profile plane. So parallel to this RPP, on the left side you got this plane. So this plane is LPP, left profile plane. Left profile plane, right profile plane, vertical plane, horizontal plane. So these profile planes are perpendicular to the both the planes, both principal planes. The horizontal plane is parallel to the ground, vertical plane is perpendicular to the ground and perpendicular to the horizontal plane. Auxiliary vertical plane perpendicular to the horizontal plane, inclined to the vertical plane. Perpendicular to the horizontal plane, inclined to the vertical plane. Auxiliary inclined plane perpendicular to the vertical plane, inclined to the horizontal plane. Profile plane, the planes are perpendicular to the vertical plane as well as horizontal plane. Okay. So quadrant system, because of the position of these planes, that is horizontal plane and vertical plane, the space is divided into 4 quadrants: the first quadrant, second quadrant, third quadrant, and fourth quadrant, because of the interaction of these planes, principal planes. So which are those in principal planes? The vertical planes and horizontal plane, and both planes are perpendicular to each other. So you can see that here. So horizontal plane and vertical plane, horizontal plane we can see it as a x-axis. If you are looking from this side, so you can see this horizontal plane as a horizontal line. So this is the x-axis. Vertical plane as a vertical line from the side. So you get a vertical line. So x-axis, y-axis, or interaction of these planes. So this interaction line, not a point, interaction line of this plane is called as a xy line. Interaction line is called as a xy line. So xy line, and this is the position of the observer. XY line, vertical plane, horizontal plane, and this is the position of a observer. And what is the reference condition of a object if object is called in the first quadrant, second quadrant, third quadrant, and fourth quadrant? So we will see that. So first quadrant, second quadrant, third quadrant, and fourth quadrant. This is the position of a observer, and this is the object. So how to give the reference of this object with respect to the horizontal plane and with respect to the vertical plane? So you can see this object is in first quadrant, means it's above from the horizontal plane. So the first word coming to the picture is the above. Above. So above means it has at some height from the horizontal plane. This object is at some height from the horizontal plane. So we can denote above like this, above. So the second word coming to the picture is the in front of. The second word is coming to picture is the in front of. In short form we can say is in front of, or in bracket IFO. In front of. So in front of the vertical plane. So what is the position of a object in the first quadrant? So this is the first quadrant in the side view. So first quadrant object is above the horizontal plane. So this is the above the horizontal plane. You can see here above the horizontal plane and in front of vertical plane. In front of vertical plane. So examples are given like the point is in first quadrant 30 mm above the horizontal plane, 20 mm in front of the vertical plane. So 30 mm above the horizontal plane. This is the horizontal plane. So here is the 30 mm above the horizontal plane. This point is 30 mm. This point is 20 mm in front of the vertical plane. So this is the position of a point A. This is the position of a point A. The point A 30 mm above the horizontal plane, 20 mm in front of the vertical plane. So point is called as the point is in the first quadrant. The object is in first quadrant means this object position is in front of the above the horizontal plane, in front of the vertical plane. So we'll see now for the second quadrant. This is the second quadrant. So similarly to the first quadrant, we have to give the reference positions with respect to the vertical plane and horizontal plane. So you can clearly see here the second quadrant is above the horizontal plane. This is the horizontal plane, this xy line. This is the horizontal plane. So you can see, so this quadrant is above the horizontal plane, and with respect to this vertical plane, what we can say, it is behind the vertical plane. So our third word is the behind the vertical plane. So for second quadrant, with the reference position from the principal planes, above the HP, behind the VP, above the HP, behind the VP. So point in the second quadrant, you can say that 30 mm above the HP, 30 mm above the HP, 20 mm behind the VP, 30 mm above the HP, 20 mm behind the VP. So we can say this quadrant is a second quadrant, above the HP, behind the VP. So first quadrant, you can say here first quadrant, above the HP, in front of the VP. Second quadrant, above the HP, behind the VP. Now you can tell me what is the for third quadrant. Look at, this is the third quadrant. Object in third quadrant. So object is in now third quadrant. This object is in third quadrant. So now check the position of this object with respect to this horizontal plane. You can see here clearly it is the below the horizontal plane. It is below the horizontal plane, not a above the horizontal. It's a below the horizontal plane. And with respect to this vertical plane, you can check it out. It is the behind the vertical plane. So for third quadrant, this is the third quadrant. So position of a object below the horizontal plane. So fourth word is the below. Below. So below the horizontal plane and behind the vertical plane. Behind the vertical plane. So below the horizontal plane, behind the vertical plane, you get the position of a object is in the third quadrant. And for the remaining fourth quadrant, where exactly position? So position is below the horizontal plane. Below the horizontal plane. So you can say here below the horizontal plane and in front of VP. In front of VP. Vertical plane VP. Horizontal plane HP. So you can see here below the horizontal plane in front of the vertical plane. Below the horizontal plane in front of the vertical plane. So position is below the horizontal plane and in front of the vertical plane. So we are looking from this side. So this picture is okay. So we'll move to the next slide. So we'll write here for the third quadrant and fourth quadrant. First of all, for third quadrant, below the HP and behind the VP. Below the HP and behind the VP. And for fourth quadrant, we can write here below the HP and in front of VP. Okay. Quick revise. Above the HP, in front of the VP, first quadrant. Above the HP, behind the VP, second quadrant. Below the HP, behind the VP, third quadrant. Below the HP, in front of the VP, fourth quadrant. So fourth quadrant system. So same thing is given in the table. You can see in the table. So here the quadrant system. The first quadrant above the HP, in front of VP. Second quadrant above HP, behind VP. Third quadrant below HP, behind VP. Here below HP, behind VP, and fourth quadrant, so below HP and in front of VP. So here some give combination observer, object and plane. You can see here observer, object and plane. So this is the observer, this is the object is in the first quadrant, this is the object in the first quadrant. So you can see the combination observer, object and plane. Observer, object and plane. And if this is the object in second quadrant, what is the combination? Observer, plane. So this is the plane and object. Observer, plane and object. Object in third quadrant. So this is the observer, plane and object. So you can see for second and third quadrant, the position is like observer, plane, object. Observer, plane, object. For first and fourth quadrant, observer, object, plane. Observer, object, plane. So you can see for the fourth quadrant, observer, object and plane. So you will get front view of this object in the first quadrant on this vertical plane. Front view of this object on the vertical plane. Front view for this object in the fourth quadrant on the vertical plane. So object, observer, object, plane. Observer, object, plane. But for the object in the second quadrant or third quadrant, you can see here observer. This is the plane. On this plane you get the projection. On this plane you are get the projection. So observer, plane, object. Observer, plane, object. Second quadrant. Third quadrant, observer. This is the plane, vertical plane, and this is the object. Observer, plane, object. I think it is clear, the combination observer object plane and observer plane object. So now how exactly it is behind the reference plane. So how exactly observer plane and object come into the picture. So you can clear it with the glass box concept. So now you can see this is the box. Box is made up of a glass material. Okay, so this is the HP, horizontal plane. This is the horizontal plane. This plane is the horizontal plane. Okay, this plane is the vertical plane. This plane is the vertical plane. Okay, if I extend this vertical plane, okay, give me some time to draw this extension. So like this. So this is the extension of the vertical plane. This is the extension for this horizontal plane. I will extend this like this. So again it becomes like the quadrant system. It is horizontal plane parallel to the ground, vertical plane perpendicular to the ground, and this is the third quadrant. This is the third quadrant. So this is the below the horizontal plane, below the horizontal plane. This is the behind the vertical plane, behind the vertical plane. So we'll see the concept of observer, after that plane and object. Observer and object. Observer, plane, object. So object is in the third quadrant with the help of this glass box concept. Okay, with the help of this glass box concept. So now consider this object is here. This is the made of a glass. So you can clearly see this object inside the box. You can clearly see the object inside this box, and we are looking from this front. So this is the front view. We are looking from this front. So you will get projection of this object. Project of this object, if it is a ball, as a circle on this vertical plane. As a circle on this vertical plane. So this is the front view. This is the front view of the. This is the front view of the object. And if you are looking from the top, you will get the projections on this horizontal plane. Projection on this horizontal plane. It's a top view. It's a top view of a object. So you can see the observer is looking from the top. This is the plane on which you get the projections of this object. So observer, plane and object. Observer, plane, and this is the object. In the front view again, observer, this is the observer, this is the plane, vertical plane, and this is the object. So you get the projections on this vertical plane. Here you get the projections of the top view on this horizontal plane. Vertical plane, horizontal plane. So this is the horizontal plane, this is vertical plane, and this line of interaction of both the planes is a XY line. Line of interaction is the XY line. Okay. Moving further. So how to draw those views on a single plane? How to convert those views, that is front view, top view and side views, into single plane? We will see here with the help of 1 and 2 examples. So we'll take a simple example of a square box. So it's a solid box. So it has some length. So this is the length of the object, this is the height of the object, this is the width of the object. So three-dimensional object has 3 dimensions. The first dimension is the length. This is the length. This is the height. From this point, this is the height, and this is the width. And we want to convert this three-dimensional object into 2D drawings, that is the front view, top view and left hand side view. Front view, top view and left hand side. That is, if you are looking towards this object from this side, it becomes, this blue part, it becomes the front view. If you are looking towards this object from the top, we got the top view, and if we were looking from the side, we get the side view, left hand side view, front view, top view, left hand side view. Okay. So object, observer for the front view, top view, side view. So these are the projections of the front view, projections for the front view. So you can see here, these projections are perpendicular to the object, perpendicular to the plane, perpendicular to the object, perpendicular to the plane. You are looking for the front view, so projections are on the vertical plane. So this is the vertical plane perpendicular to the ground. So on the vertical plane, we are getting this front view of the object, this part of the object. So two dimensions required for this front view, those are the length of the object L and the height of the object H. So this is the L and H, L by H. So this is the rectangular shape for this object, front view of the object, rectangular shape. So the projections are on the vertical plane. You are looking from the top, again which shape? This shape is, you can see this green part is looking from the top only. So this is shape is the, again, rectangular shape, and the dimensions for the rectangular shape are the length, this dimension here, length, and this width. So length by width. So for the top view, the required, so these are the projections, and we are getting length by width as a top view. And for the side view, these are the projections. Again, projections are perpendicular to this object and to the plane, and we are getting here the side view on the profile plane perpendicular to the both the principal planes. So this plane is perpendicular to the vertical plane as well as the horizontal plane. Okay, so this is with the first angle method of projection. So what is first angle method of projection? In first angle method of projection, the combination of observer, object and plane is like observer, this is the observer, this is the observer position, this is the object, plane, observer, object, plane. For the front view, you can see for the side view, observer, this is the object and this is the plane. And for the top view, observer, object and this is the plane. So combination for the first angle method of projection, that is object is in the first quadrant, is obvious, that is observer, object and plane, observer, object, plane. So if this combination is there, then it's called as a first angle method of projection, or object is in the first quadrant. So this is the vertical plane. Horizontal plane means which PP is here given, you can see. So this is your vertical plane, means you are looking from this side. So this is the position of a observer. Now you are looking towards this object from this side. So from this side you are looking. So this is from the right side. PP is on right side. So RPP. This PP is a RPP, right profile plane. It's a right profile plane. And we are going to get which view on this RPP. So you are looking from this left side. You are looking from this left side. So from this left side or left hand side view. So you are going to get here left hand side view on this RPP. Okay, we will see how these projections on the vertical plane, horizontal plane and RPP. So this arrow is for the front view. So projection of each and every point you can see here. You can see here. So from front view, this line is visible. This line is visible. This vertical line is also visible. You are looking from the front. This vertical line is visible. This horizontal line, yeah, it is also visible. This horizontal line is also visible. This line visible. So the projection for this point, the first is projection for this point. So projection, another projection is for this point. This. So if you are looking towards this object from this side, you can easily see there is the horizontal line. This horizontal line. This is the vertical line or vertical edge of the object. You can easily view this edge, that is projection for this point, projection for this point. So you can draw here vertical line, this vertical line. Again you can see here some horizontal surface, but only this edge is visible, this edge is visible. So draw the edge part, this one. Okay, whatever dimension given, make here that dimension with the help of scale, and you get this surface. So now you can see here the vertical surface or vertical edge. So whatever dimension you know from the drawing, make here the vertical line, and again horizontal line. So it's something like this. So in front view you can see this part, there is some hole, and the edges of the holes are not visible. So you have to draw the hidden lines for the hole, the hidden line for the hole. This is the hidden line for the hole. So whatever the dimension between these two hidden lines is equal to the diameter of the hole, diameter of the hole. So this is the dimension. So in front view you are going to get this type of a view. This is the front view of the object, observer, object, and the projection of these all the points on the vertical plane, projection of all these points on the vertical plane. So you are making these projections for these front side points, for this front side points which are visible from this position. Okay, now we'll see the top view. Okay, top view means you are looking from the top, you are looking from the top, and which parts is visible? So this black surface is visible from the top, this total black surface is visible from the top. So this surface you can see, it's a like a rectangle body. This black surface is a rectangle body. So rectangle body means you are going to get, if you are looking from the top, you can see like this. This is a rectangle body, the somewhat square type of a body. This again another surface connecting to this surface, and there is the hole on this square surface. So this is called as a top view. So these are the projection we are getting from the top side on this horizontal plane. So this is the top view of this object. Side view, which side view? Left hand side view. Okay, so these are the projection lines for each and every edge or edge point, end point. So after joining we get this type of a side view. So this surface is visible and this surface is visible. The hole is not visible, but this dotted line shows there is the some hole, and that hole has a size equal to the diameter of the hole. Okay, so this is the front view, top view, and left hand side. You are looking from the left hand side of from the front view, left hand side from the front view. Okay. The projections are perpendicular to respective reference plane, perpendicular and are also parallel to each other. So these are all projections are perpendicular to the reference plane, perpendicular to the object, as well as parallel to each other. Parallel to each other means projection for the side view parallel to each other, projections for the front view parallel to each other, projections for the top view parallel to each other. Okay, so now we have to draw these views on a single plane. We have to make these all the views on the single plane, and for that purpose the horizontal plane will rotate clockwise direction. This horizontal plane on which we got the top view, it rotates in the clockwise direction. Left hand side view plane, that is the RPP plane, will rotate in the anti-clockwise direction. And if the plane is this side, the plane is this side, that is the LPP, it will rotate like clockwise direction. It will rotate like clockwise direction. Okay, so horizontal plane is rotated clockwise from the left, and profile plane is rotated anti-clockwise from the top. So profile plane, so which profile plane? RPP. LPP profile plane will rotate like the clockwise from the top. Okay, so all the views or orthographic views of this object are in now single plane. How? Front view, below of that top view, and the side of the front view there is the left hand side view. On the right side of the front view we got the left hand side view. Below the xy line we got the top view. So like this: vertical plane, horizontal plane, and the profile plane. So on vertical plane, which view we got? We got the here front view. On the horizontal plane we got here the top view. On profile plane we get here the side view. So which side view? So for the first angle method of projection, on the right side of the front view we get the left hand side view. And if here we draw the side view, this side, so we got here the left side, we got the right hand side view of the object. So these are the position of the views. You can see here, these are the position of the views: front view, top view on this side, left hand side view on this side, right hand side view. Okay, so we'll see the projections of that object. So this is the front view, top view on the horizontal plane, and PPA on profile plane, left hand side view. So is there any connection between these views? Yes, there is connection. So what are those? Those are the projection lines. So you can see the length of a front view and length of the top view is equal because our object is same, so length is same. So you can see the projection endpoints of the front view matches with the endpoint of the top view. So projection for the same length, that is endpoint of this front view, that is length direction, is matches with the endpoint of the top view. Another thing, the height of the front view, this is the height part of the front view, it matches with the height part of the side view. See here, height part of the front view matches with the height part of the side view. Width part of the top view, this is the width of the top view, is matches with the width of the side view. So this dimension for the top view, rectangle of width by length. So here rectangle of length by height. So automatically after projection over the 45-degree line, we get here this part is the width, and this one is the height. Means front view length into height, top view length into width, side view width into height. Okay, front view, top view, side view. Okay. Now what is the third angle method of projection? Third angle method of projection means object is in the third quadrant. If the object is in the third quadrant, it means that the object is below the horizontal plane, behind the vertical plane, below the horizontal plane and behind the vertical plane. Okay. So now you can see here, this is the horizontal plane, vertical plane, object is below the horizontal plane, object is below the horizontal plane and behind the vertical plane. So this is the vertical plane, object is behind the vertical plane. So if you are looking from the top, the projections we got on the horizontal plane. Though you are looking from the front, the projections you will get on the vertical plane. And this is the xy line, and the horizontal plane rotate in clockwise direction. So after rotation of this horizontal plane, where we get the top view below xy line. So this is the xy line and this is the front view. You can see here, this is the top view, we get here the front view, the projections, and this is the xy line. So top view after rotation get top view, XY line and front view. Top view, XY line and front view. So why it's called as third angle method of projection? Because of the combination. You can see observer, plane and object. Observer, plane and object, or here, so observer, this is the plane, vertical plane, and object. Observer, plane and object. So this is the front view, and on profile plane, that is LPP, left for plane, we get the left hand side view. We are looking from the left, so left hand side view. So for third angle method of projection, so what we get for third angle method of projection? So this is the XY line. So front view is below the XY line. Front view below the XY line. Top view above the XY line. So beside the front view, we here got left hand side view. Left hand side view. And beside the front view, we got, on the other hand, the right hand side view. So in third angle method of projection, top view above the XY line, front view on left hand side view on the left of the front view. So this is the left of the front view. Right hand side view on the right of the front view. In first angle method of projection, so we get here the front view, below that top view. On the right side, we get the left hand side view. On the left side, we get the right hand side view. Okay. So important parts or important points in the first angle projection method. So you can read here. The object is situated in the first quadrant. Object is situated in the first quadrant means the object is above the HP. Object is above the HP. Object is above the HP and in front of the VP. In front of the VP. Above the HP, in front of the VP. Object lies between the observer and principal plane. Observer, object and plane. Observer, object and plane. Orthographic projection of the object obtained on VP is the front view, and front view always lies above the XY line. Front view always lies, so this is the XY line, so this is the front view above the XY line, top view below the XY line. Orthographic projection of a object obtained on the HP is top view and always lies below the XY line, below the XY line. The orthographic projection of an object obtained on the PP, that is profile plane, is side view. So on left profile plane, we get the right hand side view. Right hand side view. On the right profile plane, we got the left hand side view. So here we can draw here. So on this left side LPP, we get the right hand side view. On this RPP, we get here the left hand side view. Front view above the XY line, top view below the XY line. On LPP, we get the right hand side view. On the RPP, we get the left hand side view. The same RHSV is drawn on left side of the FV. LHSV is drawn on right side of the FV. Principal projections. So front view on the vertical plane, and called as a front view or the elevation. The top view on the horizontal plane called as a top view or the plan. So profile right hand side view is on the profile plane LPP, left profile plane, called as the RHSV, and left hand side view is on the RPP, is called as a left hand side view. Okay, we'll stop here. Kindly let me know if there is any questions from your side or doubts from your side. Thank you.